Hey everyone, very happy to see that so many people are actually interested in accessibility and database accessibility. Before we start, a couple of words about me. I'm a freelance accessibility specialist with a background in front-end development, design, and database. Currently, I run my business from Oslo, the capital of Norway, but I actually come from Belgium, the country of French fries and chocolate, and I will be moving to the very, very north of Norway during the next year, and I think become the most Nordic accessibility company in Europe, at least. And we'll dive right in with an example of what a database can sound like when we browse it with a screen reader, to just set a bit the bar of what it's like to be a screen reader user and browse database. Right.
In our simulations of the 2024 presidential election, Trump wins 44 times out of 100. There is a less than 1 in 100 chance of no electoral college winner. Five calculator PNG image. Harris. 555. Trump. 441. No winner. Plus. 4. 1000. Simulations. Harris win. Trump wins. One simulated electoral college outcome. Image. 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 No winner. Image. 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 Image.
Yeah, if you wanted to look at this entire chart like this, you would have to hear image 1,000 times, and you would know nothing. So how do we make this accessible? For that, I want to start by looking at nothing. Screen went black. There we go. For that, we want to start looking at web accessibility, which I think is what most of us have heard of before database accessibility. And something that comes up a lot there lately, came up yesterday at the speaker dinner, came up with a lot of my clients, it's something that's creating a lot of buzz lately, is the European Accessibility Act, and a very dreaded 28th of June 2025 deadline. And for those who don't know, there's a new law coming to the EU, which says that all products have to be accessible for people with disabilities. And from the 28th of June 2025 onwards, people will be able to take you to court if your product is not accessible. So that's why lots of people suddenly become very interested in accessibility lately. And something that goes closely together with that is WCAG, or the Web Content Accessibility Guidelines, where we have a set of testable success criteria that will tell us how compliant our website is. And maybe you've seen this view before. I'm not going to go too much into WCAG today. Those who come to my workshop on Wednesday will get a little bit more into this. The first time I saw these documents of WCAG, I was personally very intimidated by it, and I very much understand if you as developers and designers look at this and go, oh my god, so much text, so much information. But it's actually a very useful document because we have success criteria. For example, we say that non-text content should have a text alternative, but from there we can also get more information about what actually that means, who we are designing for when we comply to this, how to test this, and techniques for implementing this. So it's actually a very useful document, way more than just a compliance document. And then from there on, like when talking with designers and developers, often very practical things come up, like how do we make sure that there's enough color contrast? How do we make sure that the keyboard interaction works for everyone? This keyboard interaction, there we go. Also testing with screen readers. But the most important thing of all of that is that we are designing for people with disabilities, and we cannot lose track of that. Accessibility isn't just implementing technical specification. It's not just being audited or testing your own code. It's not trying to be compliant to WCAG or following local laws and regulations. It's definitely not like about the 20th of June contacting an accessibility specialist and asking to help you avoid fines. But it's actually about including people, and more specifically about including disabled people. And with that, there's a very sad statistic, actually, that's only 2% of websites that were tested by WebAIM did not have accessibility errors. And that's a statistic from 2020. It has gotten better. I think the latest one, they said that 97% of websites had accessibility errors, so there's a marginal improvement. But according to WHO and some data from the US, between 15 and 25% of the population has some sort of disability. Depending on which data source you use, it will be 15% or 25%, but that's a whole lot of people. And if you take into account how many people there are in the world, that's around 1.5 billion people that are excluded from the majority of our websites if we don't make them accessible. And just so we're also all on the same page about who those 25% are, it's people with disabilities that relate to visual things, like, for example, people who are blind, who are colorblind, who have low vision. And for those, it's good to make sure that our colors have enough contrast, so even if you have low vision, like, the text is noticeable. The small pink text I have on my screen, it's not going to be that noticeable currently, not as much as the black one. And those things also help people who browse the web in bad light conditions, or who have bad equipment that makes it less noticeable, or people who've had surgery in their eye and have like a temporary disability that makes it so that they cannot browse the web as well. Other things are related to hearing, for example, people who are deaf or have hearing loss. For those, we want to make sure that the sound can be controlled, that things can be paused, also that there are subtitles and captions. And that's also useful for everyone else. For example, maybe some people are also following along here on the screen with the captions, despite not being deaf, because someone next to you is making noise, or it's easier to focus if you can also read what's being said at the same time. And that brings us to cognitive disabilities. And I think I didn't follow the last session completely because I was preparing my own, but there were also some things mentioned there about cognitive load and about how we're constantly making decisions and constantly, when we're multitasking, having to balance different things. And that goes a lot together with things like autism, ADHD, dyslexia, and we want to make sure for that we have clear language, that we have a clear structure, that lots of things have like alternative formats. And lastly, mobility disabilities relate to, for example, people who have an arm amputated and therefore cannot use both hands when browsing, or people who are, have shaky hands and cannot be very precise when clicking objects, so making sure that everything works for them as well. Who of you has worked with data viz, either making dashboards or just implementing a one-off chart or something like that? Okay, quite some people. Congrats, you actually are already working with accessibility. In my opinion, if you work with data viz, you are doing accessibility work, because we actually make the visualizations to make our data more accessible and more understandable for people. If you look at this chart of the coronavirus spread in the UK, and I ask you how is the last month going, you will be able to figure it out from this table, but it's going to take you a while to read it all, because you will have to read the actual numbers. At a glance, you're not necessarily going to see a trend in this data. And it's also like, you have a number there that's 24,000 and a number that's 63,000, and they look the exact same, even though it's like one is 2.5 times as much as the other one. So then in come the visualizations, and the 24,000 and the 63,000 are suddenly, the difference is much more noticeable, because there's a small bar and a tall bar, and we can see all the patterns over an entire month at glance. And that's something that becomes even more important when we have a lot of data points. For example, here's a chart that shows the measles outbreak in the US going from the 1920s until the 2010s. So that's for 50 states for 40 years. So that's quite a lot of data points. And here, those are visualized, the actual values, like how many measles cases per 100,000 people there were, is shown by the darkness of the color. The darker the color, the more measles. We can also use the position on the x-axis to know in which year the data is from, and on the y-axis to know which state it's from. And then text and lines also give us some extra annotations about important events during that period, like, for example, the measles vaccine that's introduced. So then, without actually having to like really look at data or think about this a long time, maybe some of you have already drawn this conclusion while I was talking, you can see that there was a very high amount of measles cases, all up to the line where the measles were introduced in 1963, after which the colors became a lot lighter, so meaning the cases started to go down, and then we had a very long period of no measles. So something from this chart that you can very quickly tell is the vaccine worked. There were lots of measles cases until the vaccine was introduced, and then it got much better. You can also look at trends per area. For example, Mississippi had very little measles outbreak throughout the entire pandemic. And in 1945, maybe it was related to the end of the war, I don't know, but suddenly there was also 1 year with very little outbreak. And you can also, by combining the X and Y axis for a specific state, say, for example, for Iowa in 1965, there were still quite a bit of cases. And if you wanted to get this from a table, you would be looking at thousands of numbers to get this information from, and you would spend probably an entire day, because it's also very tiring to process all of this information, trying to figure this out, and you would probably not have as good of an experience as if you were just presented this image. And another example is a map that shows the amount of Walmart stores in the US and combines it with their median age. So here we have a map of the US, and here the color relates to the year that they were opened. So the darker red the color is, the older the median age of the Walmart stores in that area are. The more deep blue it is, the younger those stores are. Similar, the bigger the hexagon is, the more Walmart stores there are, and the smaller the hexagon, the fewer there are. And then lastly, the position on the map also tells us a bit about which city or which state the data is from. So by glancing at this, I can also tell that the... Thank you. By looking at this, I can also tell that the oldest stores of Walmart in the US are around Arkansas. I can even find out where the first Walmart stores were from. It's from the northwest tip, because that's where the darkest red colors are. I can also tell that the Walmart stores spread themselves in a radius starting from where they originated and went outwards, because in a circular pattern, the colors will gradually get more cool. Then I can also tell where the big cities are, and I can also tell that in the big cities on the East Coast and West Coast, it's where most recently most of the stores were opened. I can in general identify densely populated areas, and I can even tell on this thing, I can see that there's a high density of stores on the east of the country, and if you were to compare this with a map of the US of where people live, it's actually the exact same, so I can even tell where the people in the US live based on looking at a 600 by 400 pixel chart on my screen. And that's a whole lot of visual elements, and all of those have to work together, and all of those play a role into communicating a specific point of information. If you go back to this chart and I was to remove all the color of it, something very important would be missing. We would just know how many stores there are, but all the information about how the Walmart stores spread throughout the country would be gone. If I just had small dots instead of the different sizes, then the information about the amount of stores would be gone. So all of those parts are very important. And they all help us to put abstract numbers into context and help us look at the big data set and get both very detailed information and also summarized overview information and general trends and patterns that we can spot. And in order to achieve that, very often we're also going to need some type of interaction attached to our data viz. For example, in this map, I could tell the general patterns of the US, of the Walmart stores there, but I could not really know exact cities unless maybe I live in the US and don't know a lot about the geography there. But then I can hover over the individual hexagons and I can get some information about how many stores there are in LA, how many there are in Dallas, Texas, and so on. And something else, a form of interaction that's often attached to data, is filtering. Here I have a data table with lots of scientific papers about birds, because one of my hobbies is bird watching and reading very nerdy papers about them. And I have a Notion file where I structure everything and keep track of what I still have to read and which subjects they're about. And then it's very easy to use the filters and filter on a specific bird that I want to read about, or filter about a specific subject, and my table will adjust. And that's also something we will have to take into account when it comes to accessibility, how the filters we apply to our data is then going to affect the experience of the person looking at it. Because suddenly we go from a data table with a lot of information to something that's fixed on a specific viewpoint, and maybe there's a different reason for why you're looking at it, and maybe there's different insights you're after. So then we get to the fun part, and that's creating some guidelines for this and trying to figure out how we can make those charts actually accessible. And I earlier mentioned WCAG, the Web Content Accessibility Guidelines. We can find some information about data viz in there because, for example, the non-text content example I showed, that can relate to data viz. It's non-text. There has to be a text alternative to it. But it's quite limiting WCAG. And something that's filling in some of the gaps there is a tool created by some data viz practitioners who created something called Chartability. And it also creates a set of success criteria, but specifically focused on data viz accessibility. So for example, how do you check that interaction is available throughout different ways? How to make sure that instructions are provided, or how to test that instructions are provided, and so on. So if you want to check for yourself if your data viz is compliant, you could use a checklist or a compliance document like this as well. I'm not going to go through all of the points, but most of what I will talk about in my next slides is based on information that you will also find in here. And one big one is color contrast. I think it's probably one of the most talked about parts of data viz when it comes to accessibility. It's also when I myself got into data viz accessibility, one of the first items that I came in contact with. I was wondering 6 years ago, how do I make this visualization that I'm working on more accessible? And back then when I went to Google and I typed data viz accessibility, the only thing that came up was related to color and nothing else. So it's a very popular subject. And basically what we have to do with color contrast is making sure that our elements have sufficient contrast against their backgrounds and against each other, so that people, even with vision loss, will clearly be able to see them and be able to see all of those patterns on the charts we talked about earlier. And there's the 3.1 contrast rule. So graphical elements should have a color contrast, and I'll in a minute show how you can test this, of 3/1 with their background. But then to make it a bit more fun, they also have to have a 3/1 contrast with elements that directly touch them. Like this pie chart, it has two dark colors. It has the dark blue and the dark green. We have to make sure that the dark blue is having enough contrast against the light background, and also that the dark green is having enough contrast against the light background, but also that they have enough contrast against each other. And in this example, they stand out very well against the background, but not enough against each other. So someone with vision loss or someone looking at this with a screen that has low brightness might not actually see that a quarter of this chart is in dark blue. And this becomes increasingly more complex the more colors we add to our charts, because in the previous example we only had to look for 3 colors. Now we add a third color to our pie charts, and suddenly we have to check if the pink is having enough contrast against the green, if the pink is having enough contrast against the blue, if the blue is having enough contrast against the green, and if all 3 of them are having enough contrast against the backgrounds. And the more colors you're going to add, the bigger your matrix of color contrast is going to be, and the harder this is going to become. So then in come a couple of tricks that we can do, like for example, adding darker borders around elements. This works well if they're like freestanding, because then you don't have to think about the fact that the light pink in this chart doesn't have enough contrast against the light yellow background, because the border has enough contrast. And I can also add a gap between different elements. This can maybe work a bit on a simple pie chart like this, because by adding a gap between the elements, we no longer have to check the touching colors between the elements. It's just going to be the background color. And we can test this as designers while we are designing in Sketch or Figma with plugins like Stark or Able. I mostly use Able in Figma. If you're working in the browser as a developer or as a tester, you can use, for example, X, or Chrome has Lighthouse built in, which will also check for color contrast. If you're neither designer or developer and you don't feel like playing with any of those things, you can also go to the WebAIM color contrast checker. If you go to Google and you just type WebAIM color contrast, you will get to it, where you can add 2 values, and it will tell you whether the contrast ratio is high enough and in which circumstances you comply to WCAG. And one of my clients actually made a new tool a couple of weeks ago, which is called dataviscontrast.com, which also takes the thickness of lines into account, because a thick line on a chart, like a thick bar chart, might not need to be as high contrast than when you're working with really thin lines to visualize something. The next color-related item is colorblind friendliness. That I'm not going to go too much into detail about, but I think most people know that green and red are dangerous colors to use in combination. And that was actually the very first thing I discovered when I started working with accessibility. I was working for a company that made data viz platforms for cancer research, and we had to do risk management to make sure that no mistakes would be made and no patients would be killed due to our interface. And as part of that, we discovered that good values and bad values were like coded as green and red, and that for someone trying to select a good gene to put in a cancer vaccine, that's quite problematic because they might accidentally select the wrong one because of that. And at that point, it has way more implications than just the application not being accessible for this one person, but it being inaccessible for this one person would also have consequences on the general population. And that's when I started looking into data viz accessibility and into those things. And to test that, we can also, again, use plugins in, for example, Figma. There is the color blindness simulator that copies your artboard that you have selected with it and changes the colors to simulate what it would look like for different types of color blindness. And, for example, Firefox also has an color blindness checker in the accessibility tools that will simulate this. But the biggest tip regarding to color is to not rely on color, because here we have an example that uses color with blue and red to code Democrats, Republicans. It's generally a quite known color combination, blue for Democrat, red for Republican, but still the chart added in context the label Biden and Trump on each side right next to the color, and also even added the face of each candidate, so you don't even have to read. You see that Biden has Biden's face has a lot of dots next to it. And what we also saw in this chart is that graphical objects are explained. Even if it's so clear in context, it's always good to have a legend, which is something all the charts that I've shown so far have done as well. This one has a color legend on top and has annotations in context. And the chart with the Walmart visualization even had a little bit of text explaining how to read it. Next up, we also want to make sure that our data exists in different formats and that we don't just limit ourselves to one table or one bar chart or one line chart. And that's, again, to take it back to this cognitive way of, like the cognitive load and different ways of thinking. Some people might have trouble reading numbers, or some people will prefer things being explained in text, right? Like the text already being processed for them and telling you the exact things you should look for. Whereas for other people, for example, with a language barrier, they might not want to have a lot of text to read, they just want to have a chart to look at. So again, this chart, it's a good example because it uses so many of those concepts in one. It has a text summary on top of the card that tells you already what you can learn from this chart. Then it also summarizes it in numbers, and it also summarizes it visually in proportions. And in dashboards, this is the type of thing that you might see where on top of the dashboard, you have some cards with statistics. Underneath, you have some high-level charts. Then you have some charts that you can really drill into, and then you have a data table, for example. And data tables are, even though I said that we're making charts, to make data tables more accessible, data tables are still a really good thing to have because they give a really objective view into the data and a really internationally recognized pattern into it. Once you know how to read a table, you know how to read any table on the web. You don't have to relearn how to use and interact with this chart. And that again brings us to the most fun topic, making sure people have an equal screen reader experience. For those who don't know, screen readers will base themselves on the HTML we write. So when we write HTML, that's translated into the DOM, and then the screen readers will use the accessibility tree, which is based on the DOM, to present content. What this means is, for example, if I use the button element, a screen reader will announce to the user that this is a button, and in this case, in VoiceOver, it will tell me you can interact with it by pressing Control-Option-Space. This is something that no matter which button you will land on, if it's coded as a button, the screen reader will always hear it in the same way, which also helps with the cognitive load as a screen reader user. Similarly, when using semantic HTML and when being mindful of the roles we use, screen reader users can also access this heading menu, where they can get an extracted view of all the headings on the page. And that's really useful because you can scan the page the same way we do it visually. Like if I want to know who develops WCAG, if I was on the WCAG page, I would quickly scroll through it and look for a headline that says who develops this. A screen reader user can do this by looking at the heading structure here. And there's also similar menus like the landmarks menu, where the navigation and the headers are added into, and there also the area labels or the accessible names we use will be added to it. And if we didn't do this, those menus would be completely empty. If our entire website was built with spans and divs, screen reader users would already miss out on two very important navigational elements, in addition to a lot of other context being gone. And that's one of the reasons why writing semantic HTML is very important and why developers play such a big role into accessibility. And how can we apply this to data viz? Well, one option is that if we have a chart, we turn it into an image with alt text. We add the image role to it, and we add an area label with a summary to it. And that's something that can be detected by automatic testing tools. For example, Lighthouse will check if image elements have an alt attribute or not. But what automatic checkers cannot do is check the quality of our alt text. If I show you this picture of the gull that lives on my balcony, is this a photograph? Is this a bird? Is this a European herring gull? Or is this some kind of detailed description of the artistic vision of the picture? And that's going to depend on in which context I post this. If I post this in an online museum, I probably want to go for something artistic that also talks about the color and the general vibe of the image. Whereas if I'm making a list where you can see all the birds that you can find in Oslo, I will maybe just write herring gull, because people are in that case not interested if the herring gull is photographed against the dark background. And the same with the chart we saw earlier with the measles vaccine. If you're posting this as a poster somewhere or as some additional information in a newspaper article for the general public, we're going to go for different language than if we publish this in a scientific paper where scientists who contributed to the vaccine and whatnot will want to explore and learn things. And yeah, alternative text in itself can come with some limitations, because it's not always that just the text is enough, and sometimes you will want to interact with the data and find out specific patterns. Like in the chart we saw earlier, it wasn't working, but maybe you would want to know in how many of their simulations Kamala Harris wins with a 200 electoral vote margin. And to demonstrate how accessible the web actually is, I tried looking for some more examples of this.
Image, 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 image.
I'm not going to put you through the entire thing again, but basically whatever graph I have selected while making this presentation, I came across so many where there was no screen reader interaction attached to it, besides the elements that were already on the page that got announced. So how to improve this? A very good example of this is this chart made by HiCharts. They're also a charting library that you can use to make your charts more accessible because they come with built-in accessibility tools. You still have to configure them. You still have to say which behavior you want each element to have, but they really guide you through it, and it's a really good charting library to use. But basically, one example of what you can do is to turn your charts into tables or lists semantically by adding roles and area labels to the different visual elements. And now we're going to hear a good example.
NVDA, line 106 with 6 data points. This is the most used screen reader in 2019. Region 1. December 2010, 34.8%. NVDA, image 2. May 2012, 43%. NVDA, image 3. January 2014, 51.2%. NVDA, image 4. July 2015, 41.4%. NVDA, image 5. October 2017, 64.9%. NVDA, image 6. September 2019, 72.4%. NVDA, image, end of. NVDA, line 1 of 6 with 6 data points. JAWS, line 2 of 6 with 6 data points. NVDA, line 1 of 6.
So yeah, there each of those lines, so the entire chart was created into a list, and each of those lines was a list item, and then it was a nested list with more list items underneath. And it's nice to do it that way rather than just randomly adding area labels to things. First of all, because just adding area labels to things without the role would not make it WCAG compliant, but also because this gives us patterns for screen reader users that they're already used to from other products. Lists and tables and other components are something we encounter all over the web. So the combinations you use to navigate them, it will always be the same. So if we base our graphs on those known elements that are also semantically correct, then we're giving people a way of navigating that they're really used to, and that will make it much easier. Here, designers can help by documenting in their designs what kind of behavior they're expecting and who they're designing this for. But when it comes to testing, there's not that much automated tests we can do for this type of graph. We can check if the roles and area labels and stuff we've applied, if those specific combinations are technically WCAG compliant, but we can't really automatically test if the entire experience of browsing this graph is something that makes sense. And that's why it sometimes becomes a bit difficult to make those charts accessible, and also why it's good to always have a table, again, as an alternative. Because tables also come with specific interaction patterns. You can, as a screen reader user, browse them vertically or horizontally, and when you move between cells, it will announce the table heading. So it gives you a lot of easy ways of navigating between the different cells. And my final tip, I could go on for 2 more hours about this, but my final tip would be to not get too focused on the viz part in data viz. Yes, it's data viz, but it's also data. And we're using visualizations to make the data more accessible and to communicate the data. So this is a map about the locations of Walmart and when they opened. It's not colored hexagons with variable sizes on a map. So we have to think about what are we trying to communicate? What type of values are we dealing with? Is it years? Is it binary 1-0 data? Is it numbers of how many corona cases there are somewhere? We also have to think about what level of detail is needed. Is it just an illustration in a news article, or is it a data explorer for a scientist? What are the most important trends and values that we want people to look out for? Who will interact with this? Will people interact with it or just look at it? What kind of context will it be used into? Is it part of a larger process of completing your job, or is it just a one-off thing? So that really illustrates that accessibility isn't just about compliance, it's about designing for inclusion. And for that to work, accessibility has to be part of the entire process, not just something that designers or developers do at the end. And quick couple of words about this is that the typical process that I see is people research what they're going to build, they design it, maybe in between they prototype it and test it with some people, then they develop it, they go through the QA process, and at the end of it, they're like, hey, we have to make this accessible. And if you're lucky, this happens right after they've finished implementing it, But in my experience, it's usually very long after, sometimes years or decades afterwards, that they come to me and ask me to help them. And what I've noticed is the longer you wait to make something accessible, the harder it becomes, because the deeper ingrained the inaccessibility becomes. It becomes ingrained in your processes. You're not used anymore to test. It becomes ingrained in the components that you use. Suddenly, if you want to update one thing, it affects 2,000 2,000 sites instead of just this one thing when you just start designing it. So instead of thinking of it at the end, it's best to think of it at the start and then let it influence each of those steps. So research who your users are and how disabled people might interact with your products. Design for accessibility in the prototyping step already includes some screen reader things you can test and so on. Because at that point, we can use accessibility as a method to think about data. And we can think about the content and about the structure of it and about the functionality it has. And at that point, we're at a place where accessibility will lead us to better visualizations. But we do have to keep in mind that we're doing it because it's the right thing to do, not just because we want better viz. And I think there will be a round of QA soon. And if you have questions for me, you can also find me on FOSSHEIM.io, on Mastodon, or on email.
Thank you so much, Sarah. All right, feel free to join me for the conversation. We have so many questions, and thank you so much for all the practical tips. Maybe I'll just start right away, kind of jumping in. I mean, every time I see 98%, 97%, that's always like every single couple of months, like a light bulb moment. It's been like this for I don't know how many years, right? And the question that there are many questions around that. One of them was, so of those websites that are not accessible, how many errors do they have on average? What are we talking about?
I think the statistic with the data from 2020 was around 60 errors per page on average.
One question that was kind of building up on top of that, I don't remember because there are many questions that are coming in every now and again. Some of them were around the topic like, so it's difficult to make every page fully accessible. At which point and what kind of errors are considered to be maybe acceptable, and which ones are really severe?
So one first thing you can look at is the ones that are on WCAG listed as 1A or double A's. Those are like the most important ones. But more than that as well, when thinking about how much accessibility to think of in each step of the process and stuff, it's also important to think of the fact that it's a progressive enhancement kind of issue as well. It's not a one-off state, and it's not you go in and you fix accessibility and then it's accessible for the rest of the span of the website. So gradual improvements are always better than no improvements. The fact that the statistic went up from 98 or down from 98 to 97%, it seems insignificant, but it's still a really important thing because it has gotten a little bit better. So as long as you're making improvements, it's a good thing already. Then the second thing is look at WCAG. And the most important thing is talk to your users as well and try to look for the ones that are actually blocking them or really creating a disruptive pattern in their workflow.
That's very interesting because I think that we've been speaking quite a bit about testing for accessibility in different ways. But I think I'm yet to hear, or maybe today, was one of the first times when I heard the notion of testing accessibility for data visualization specifically, right? Because of course, when you're designing dashboard, right, or anything similar, then you need to make sure that first of all, the data is accurately represented, that people can understand what the data is actually telling them, and then they can perceive it because it's accessible, right? And so this was really interesting. And I think there is this notion that also came up in the Google Doc. If you ever wanted, let's say, to measure UX, there is a system usability scale. Anybody knows of it or heard of it? SUS, maybe a few people. So it's kind of a way to measure UX, right? Where you basically run a survey, you ask people a couple of questions, what the experience was like, and so on. And I think it was Fable, as a company, who ended up creating this AUS, which is Accessible Usability Scale, where they test or measure the usability of accessibility. And the point is, if somebody is using a screen reader, and they're going to be given a task, so here's a data visualization, what are the insights that you get from that? And if they accurately can understand what the data tells them, then you kind of get a high score. And so I'm wondering, is there sort of a way to measure usability of accessibility, I guess, or to maybe go again, maybe not necessarily just being compliant, but really think about the usability of those accessible solutions, and maybe something that you're using?
Yeah, I think what you're describing already, I think it can just be applied to accessibility as well. Like, not just think, like, how good is this usable to someone, but put it in front of someone and ask them questions, the same way you would do with any other UX interview. Like, if, for example, with the Walmart stores, I would, for example, ask, can you find me where the oldest Walmart store is? And then check, like, I come from a very, when it comes to UX, I don't come from a quantified background where I will try to put check marks, they can do this, they can do that, but we'll more look at how do people interact with things and ask more qualitative follow-up questions. What was difficult in their process? At which points did they have to like stop interacting with the screen reader and start thinking about the controls?
Yeah.
How many times did they have to go back or had to restart their flow or got confused? So giving them specific tasks to complete and then observing how people interact with it. But there's also something with that though. In order to test with disabled people or specifically with screen reader users, I would really advise that you do a base level of accessibility tests yourself. Because if you show a map like I showed earlier, where it's image, 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 you're not really going to get any useful information from that, besides it's just as image, and you wasted everyone's time doing it.
That's reasonable. Talking about images, there is a big question about alt text. I'm just going to read it out, but maybe shorten it a little. And nowadays, many CMS require you to provide alt text. However, I've learned that some images are purely for aesthetic purposes and don't add any value to the content. Do you think that every image should be required to have an alt text? Should it still be possible to leave it empty? Or when is it better to remove it altogether?
Yeah, images, as you say, that are just purely decorative, they should not have alt text. For example, the dog or fox icon in one of the charts, it read out like dog.png or something like that. That type of thing, it doesn't bring any value to anything. It's just a little bit of branding to show, hey, it's us who made this chart. That would be a place where I would say it's not required. And also, if you don't want to have alt text, you should not leave out the alt attribute. You should add it, but with an empty string. Otherwise, the screen reader will still announce image without anything. But if you have image with an empty alt text, then it will not announce anything. So I personally, I'm a bit against it when a tool forces you to add alt text on everything, because it might also, in that case, lead you to a situation where you have the little fox and someone writes like 5 paragraphs of text in detail explaining this little icon that had no meaning whatsoever. So instead, I think it would be better if CMSs would give you the option, either is this a decorative image and then the CMS hides it for you, or is this an image that needs alt text, you add the alt text, or maybe even going a step further and saying, is there an alternative experience somewhere for this image that the CMS can link to?
Right. Shep, hello Shep. Maybe internet Shep? No, Shep here. Oh, right, here. Is wondering, as keyboard navigation via tab is pretty linear, would you say it would make sense to add bidirectional navigation via arrow keys for interactive charts via JavaScript to allow users to move faster between data points?
Yes, and that's something that, that a lot of charts, when they're made properly keyboard accessible, you will have some kind of way of moving between the data points. And in some places that might be just directional, up, down, left, right. Yeah. But maybe it could also be that you jump between groups at first and then use a command to enter the group and then go into each of the data points within the group and stuff.
Yeah, I think that one of the really major things in accessibility, which really changed everything for me at least, is when Microsoft released the Inclusive Design Toolkit, where they were looking at accessibility through the lenses of different situations in which you might be, like permanent disabilities, temporary disabilities, and situational disabilities, when we kind of all happen to find ourselves in at one point of our life or another. I think that really changes the way of how we think about accessibility. And this changed the perception for me, because we have the notion of accessibility, which is often considered to be, I guess, a technical accessibility, like front-end stuff, and then we have inclusive design. So how would you draw the line in between? Or is one more design, and the other one more technical?
I would say there is no line in between. Everything is inclusive design, and one of the consequences of it is that developers will have to make their code work in a specific technical way. Or at least that's how I look at it, because you have the requirements and you can look at it as a very technical requirement system, but in the end, as I said in the start of the presentation, those are there to make sure that people can use the website. So to me, it all hangs together.
Okay, makes sense, makes sense. We have a very challenging question from Sasha. Here, right here, Sasha is wondering, do you believe, I'm just quoting here. Right. Do you believe LLMs and AI could help make complex visualizations more accessible automatically, like creating visually hidden summaries that could be used by screen readers or in any other way?
I'm very skeptical about it, because I think technically you could probably train an AI to give you some kind of summary, and if you very much curate it and you really, as a developer and designer, think of how you're going to visualize the uncertainty of the data you get back, and you do a lot of quality control, you might be able to come up with something that's right in some situations. But there's so many different kind of human little nuances to how we write alt text or how things should be visualized in different ways. A line chart that, for example, shows the coronavirus over the span of the past 4 years might need a different type of summary than a line chart with just as many cases, or just as many lines that shows, I don't know, the screen reader usage over the years, because it's a different meaning behind it. And then again, the type of people that will use it, even if it's the exact same data, like the measles virus charts, if you put it in a newspaper, the case is going to be different than if you put it into a scientific paper. And if your science audience are scientists who develop the vaccine, the use case might be different than if it's scientists who work in a completely different field, who have the scientific knowledge but don't have this specific knowledge. So there's so much going on, and on top of that, there's also that AIs don't really know yet how people use screen readers and what kind of requirements blind people and other people who use screen readers, for example, have when using it. Like AI doesn't even know yet how we as able sighted people use it, so how would it know how, yeah. So I'm skeptical.
That's okay, sure, sure. And maybe the very final one, very short one. A concerned citizen writes, probably looking on the slides, he or she or they ask pie charts then, yes or no? That's all. That's there is no more context to it. Apparently
very
pie charts.
engineering answer, it depends. I think there's a lot of limitations to it, but I think once in a while a pie chart, in some situations, it can be, like I used the pie chart somewhere to show the 98%. I think whether you use a bar chart, a progress chart or a pie chart in such situations, it's not really that bad. But then when you look at the examples where you have like 10 different types of colors that have to be made accessible on there, and you still have to be able to read and interact with them, at that point it becomes quite of an issue.
Yeah. So if a concerned citizen is in the room, you can ask further concerning questions about accessibility and data visualization maybe later in the fireplace, where of course Sarah will hopefully join us as well after this. I want to thank you so much, Sarah, for being with us. It's been a pleasure.
Thank you.